Yes, well, thank you for having me. I am excited to talk. I didn't even know that this competition existed until you emailed, so that was very, very fun to see because if this was something when I was in college, I would have been all over it. But let me share my little thing here. Uh, let's see if this works. Oh goodness, Zoom is going crazy on my screen right now. I hope that you can you hear me or can you see the slides at least? Because Zoom just like went insane. Okay, here we go. All right, so this was my first cluster that I ever built with SBCs. This was some Raspberry Pi 3 Model B pluses. I think I tried building one with Model 2, but it was just way too slow. So the reason why I got into it though was I wanted to replicate things that we were doing in production for, I was helping with web applications at the time. And this fits on my desk. The clusters that we were deploying in production didn't fit on my desk. And it was way slower and it was way more annoying in some senses than just using the cloud infrastructure we had. But it fit on my desk and I could run things and not have to rely on the internet and rely on deploying things over the cloud and having extra infrastructure running 24/7 that I only used like during the work hours. So this was kind of cool, and it let me have a little budget for these things and have some fun with them. The other thing that I got into over time was you have lower power requirements, so you could do more things in more places. This was me testing a cluster of compute module 4s on the road with a battery and solar panels. That's something that you're not going to be able to do if you get some like Dell rack mount servers and try to set them up. You're going to need a lot more solar and a lot more battery to run one of those for more than a couple hours. So it gives you that portability, but there's also something that I've learned over time is you can go to extremes that also cause a lot more pain. This was the smallest I ever got. That's four or five. There's 5 Raspberry Pi Zeros. This was absolutely painful. I don't recommend it at all. You can see compared to the Banana, it's very tiny. And it would fit in my pocket, but don't ever put that many Wi-Fi radios that close together. I think I was getting like 3 or 4 kilobits per second of bandwidth. So things like HPL were just out of the question over that kind of link. So that was too small. So I went back to the Pi 3B Plus. I did a lot on this. And one of the things that I did was I took the opportunity to use some GPIO headers and built my own little RGB LEDs for status. Because, Grafana and other dashboard systems are great, but you have to have a computer up and see that. It was so cool to build this into the cluster. And I learned how to use GPIO on the Raspberry Pi through this. I practiced some soldering skills, little basic electronics like putting an LED with resistors and things. So it got me into a different headspace too. Something cool to do that you can do with SBCs that's a lot harder to do with servers. The other thing that was great about is when you get into clustering, one of the best things about clustering is blinking lights. When you have lots of lights and they change colors and they show you statuses, that's like, it's an aesthetic thing that you don't get when you just have one boring computer. So it's fun to be able to do that on a small scale. I kind of productionized this setup and used it. I took this on the road with me all over the US and a couple international trips to show off what I called the Dramble. It was a cluster of servers that ran Drupal, which was the web application that I was deploying the most back then. And of course here I upgraded to Raspberry Pi 4s. I used power over Ethernet to keep the cabling nicer and tidy. I used NeoPixels, which could do more colors than just the RGB LED. So this was kind of like the height of my Raspberry Pi 4 era. And I even tried to scale it up, but I started running into problems of like, it's just too big, too annoying to have big switches to deal with this stuff. So eventually I got in contact with a company that was making a board for the cluster, which tidied things up quite a bit. These are Compute Module 3B pluses, so they were back to a little bit slower, but I could fit 7 of them on a little board. And that was cool. Management was great, but you might notice there's only one Ethernet port there. And then I learned, like, it's great to have all these computers together, but you're also getting more bandwidth constrained now, and that's no fun. So moving along, I worked with them and gave them some feedback, and the community gave them feedback, and we came up with this board, which is the Turing Pi 2, which this one got up to 225 gigaflops on HPL using these Turing RK1 chips with the Rock chip RK3588. And I noticed that some of your clusters have that chip, and it is right now pretty much the best in terms of performance per watt and per dollar that you can get with SBCs, but the current RAM pricing situation is definitely throwing us for a loop. But the best thing is with all these things, you can really you learn how to balance the budget, which $6,000. You can do some generous things in there. You balance the budget with the power efficiency, with the ease of deployment. Different systems can run different OSs a little easier or harder. The support from the vendor, all these things factor in, and these are things that don't just apply on SBCs. They apply when you're building large-scale infrastructure too. The craziest thing, though, is with all these boards that I've been building, like this supercomputer here would have appeared on the top 500 list, I think, in 2006. So 20 years ago, this would compete. It would be at the bottom of the list, but it would compete with a system that cost $1 million. The system that Weta Digital used to render Lord of the Rings. This board would compete in that same class 20 years ago. It's a system that's probably a little bit more than this, but if you had a $6,000 budget, you could probably hit that, which is crazy to think about. Like 20 years from now, the supercomputers that are doing our weather calculations and stuff, and the AI clusters, will we be able to do that with SBCs? Probably. Well, as long as the world doesn't just go backwards and have no RAM available ever. But I even, I scaled down again, trying to see how small I could get. Cyped makes this little thing called a nano cluster. Those are 5 compute module 5s. You could fit up to 7, but you quickly run into things like power limits, heat limits, thermal throttling, and things like that. And even with the fan running full blast and only 5 of the 7 slots full, this thing overheats, it gets slower, there's power flakiness, it's running over PoE, so you need to have a really good PoE switch to give the power. So again, you learn all these lessons. By scaling down, you learn like what is the scale that you start running into problems that you just can't avoid, and then you kind of go back up from there. So all these different clusters that I build, I learn things. This one I learned, when you're using development boards, you might have to break things out to figure out if the board is the problem or if it's your hardware or your software. And I'm sure that some of you have seen a mess like this develop. This is actually very clean. I don't know if you've ever had the situation where your desk is just wires, cables, SBCs, Ethernet cords, patch cables that you've custom made, all that just splayed out everywhere. That's about how my desk gets on a weekly basis. But since this is my full-time job, I get like an hour or so every week to just clean things up. And so that way I can at least keep some management of this disaster. You'll be surprised to know that technically these framework mainboards are SBCs because the SoC and the RAM is soldered on. So it's just like a Raspberry Pi. It's just a way more expensive, way faster one. But again, all the lessons that I learn on the SBCs scales up as you get more power. So this system has 512 gigabytes of RAM. This only has 2.5 gigs Ethernet, so it'd be nicer to have faster interconnects, but it's neat to see things scale up. Like the software that I use Ansible to manage everything, and the applications we run with Bliss and with all the different clustering systems that we use. I use Kubernetes a lot to run applications. It all scales from the SBCs all the way up to real hardware, and then beyond that to cloud systems. And it's also interesting. Like I've worked with this company, DeskPi. They asked me, like, what do you want in a board? And I was like, I want to put as many SBCs as possible in as little space as possible. And again, we find out, like, with that many SBCs and that little bandwidth, we have some issues. So they actually, this week I was testing this, which is great for this talk. Like, gives me motivation to finish this testing. We actually scaled back down again. There's only 4 on this one and not 6. I don't know if you can see this. But it's the DeskPi Super 4C. But we found out that 6 is a little too much for 1 gigabit of bandwidth. So we're going back to 4, and we're adding more ports so that you can get all that bandwidth out of those Raspberry Pis and build a better cluster. I go back and forth with different cluster setups. This was the Blade cluster. This one was annoying because there's just so much hardware to deal with, and I'm sure some of you get, like, if you do things once, twice, or 3 times, you're like, yeah, that's okay. But once you do it 5, 6, 7, 10 times, and then you have one node that's failing and you got to take it out. If you do the wrong thing with your cabling or the way that you put things together, Or like my first clusters, I had them all screwed into each other on top of each other. If you have a problem on node 2, you're going to be sitting there unscrewing little screws for like 30 minutes just to get that thing out of there. So you learn things along the way about what's better to do and what's not better to do with cable management, with putting things together, using what type of hardware, even the types of screws. Like I try to standardize either on all hex or all Phillips, because you don't want to sit there with 3 screwdrivers switching them out all the time. But lately I've been getting into these mini racks, which is great because now I have a little box that I can take and put anywhere. And again, it fits on my desk. And I can build clusters with power over Ethernet. I can use USB-C. I can use whatever power systems. I even have, I'm testing a few different battery backup units for them so that I can have everything self-contained. And I help my dad with that too when he deploys these things out to like tower sites for radio stations. So the great thing about all of this, though, is everything that I learn on all these. I noticed some of you are using like Orange Pi 5, NVIDIA Jetsons, a couple teams Pi 5s, Pi 4s, or even just a mixed workload. Or I saw somebody had like just a hodgepodge of different like mini PCs. That's probably right now the best value, actually, whether or not that's the most power efficient. But I've noticed that like every time that I hit scaling limits, it's time to move on. And you know, this was the biggest. I don't know if you could still call this SBCs, but the lessons that I learned on all those tiny computers and the tiny clusters. This cluster costs 10 times more. It's 100 times faster, but I could still utilize all that power and manage it efficiently. To, you know, if you were working in a company to get as much value out of your hardware as possible, the lessons you learn on SBCs will quickly give you the skills to like do everything that you need to be very valuable and helpful to build this kind of infrastructure. But yeah, I need to find, oh, there's the control. So stop share. So yeah, that's kind of a walkthrough of the SBCs that the SBC clusters that I've built over the past 5-10 years now. It's been 2014. I don't know how long ago that was. More than 10 years. So a lot of different SBC clusters. I built them throughout the life of my YouTube channel. And right now we're at a weird spot where the value is a little less building SBC clusters because of the RAM pricing and the way that that goes. But I think we'll get back to that again. And it's just nice, though, for me to have low energy use, high efficiency, and keep learning on every cluster I build. And that's why I love this competition in particular, because like anybody can build a cluster of commodity servers. That's what they're made for. It's a little harder when you're using SBCs that are not made for this kind of stuff, especially when you have throttling and power limits and things like that. So anyway, I think this is an awesome competition. I'm excited to see who's going to take the crown with all these tests. And I like the balance, because it's not just like who's the most efficient or who's going to get the fastest. There's a lot of variables at play, and you can be creative with the way that you cluster things together. But yeah,